So the clouds ruined the conjunction, but I'm so happy that I was able to get a picture of it. It's gonna, like, whenever we see it again. So hooray! The clouds literally parted for just long enough, and we just now have a little bit of a break in the clouds. So at least we can take a look at the moon together. So just thought I would show you this. So we're now focused on the moon. You might notice that it's a little bit like wobbly, and the reason why that is because the air above us is incredibly turbulent. And so you actually see it be quite wavy if you were looking here with me, sitting in front of the computer. So if I were to image this, what I would have to do is basically start taking a video, and then I would upload the video into some special software in order to stack each of the individual frames in order to get a nice crisp image. But I'm not taking any video now, just looking at it to show you some key features. What we're looking at right now is a line along the moon called the terminator. That is the day-night line. And you see all along the terminator, that's the best place to see really interesting features like mountain ranges, like craters, because they're in relief. So they're not being illuminated directly by the sun. And so you can see, for example, in this crater here, you see there's a peak in the center. That's where an asteroid crashed into the moon, and the moon was so molten and there was so much energy that the middle peak formed much like a water droplet does when you drop water onto a surface. Some of these craters, for example, in some of the poles, are constantly in shadow, and so there actually is water ice there that maybe future missions to the moon could potentially harvest, but there's a lot of technological hurdles to overcome. You have large expanses on the moon that are this dark color. Those are called the mare. These are basically old lava fields that flooded impact basins from basically around the late heavy bombardment period of our solar system. These are old basalt formations due to lava. And you can see this really sort of bright region up here. That's another impact crater. And you'll see there's some of these bright white rays emanating out from that crater, and those are basically ejecta. So an object came in very fast, boom, hit there, and ejected material out in these straight lines that you see from that crater. So this is what we would call the first quarter moon. It's going to, every night from here on, for the next couple of weeks, will be partially more illuminated each night until full moon, of course. And I think this is really the best time to see the moon because it, like I said, it's not directly illuminated. It's sort of partially illuminated at an angle, and so you really see just gorgeous detail of these mountain ranges all along the terminator. And if you stay with me, I can move it so you can see the sort of lower part of the terminator. Now I'm using the hand control of the telescope to slowly track towards the other region. And what's happening is clouds are moving in front of the moon, so you'll see changes in brightness. And also, of course, the software is automatically adjusting for changes of the scene. I think this is one of my favorite regions of the moon down here. This large impact basin really has these stunning mountain ranges. I mean, these are literally, really the equal or the superior to things like the Alps, the Andes, right there on the moon. Yes, Manny, I am controlling the scope I have outside. For those that are curious, like where the hell I am, this is my telescope. So we have the main body of the telescope here. This sort of reddish piece here is the camera. And then we have another smaller scope attached to the top here. This red light is an automatic tracking indicator, which means that this piece of the scope is coordinating with the computer embedded in the base down here where this other light is, and is now tracking an object that it is locked onto, and that would be the moon here. I have a smaller little finder scope here on the side, which if you look in, you see the moon, and there's a crosshair, so that allows me to very quickly just point the telescope at bright objects in the sky. And then this is sort of the inside of the observatory. It's a small little injection molded clamshell thing. And so I can close the dome like this. And if I can just also rotate the dome as well to be able to, position the telescope accordingly. This pattern you're seeing, this sort of laced pattern across the surface, sort of hatched, is actually the pattern of the CCD sensor in the camera. And so actually once I stack the images of the recording, I can actually process that out. So if I'm going to take an image, so let's say we want to adjust the brightness here, so I can just come over here. I could even reduce the gain a little bit. And you'll see it gets darker. Increase it a little. I think that looks nice. And then if I want to come over here, I can just do a quick capture, start capture. I'm going to do a single frame. We're just going to do the moon. We'll do a sequence of captures. We're not going to wait any between the captures. We're just going to let it go. We'll take 5 captures. Oops. And then before we start, we need to get it back in the position we want it. Because I want to make sure we get that really cool mountain range, like right in the center. So we'll move that up there like that. Get as much of the terminator as we can. And you'll notice that the full moon is not in frame right now. And that's because the size of the telescope I have, it's really hard to get such a large object like the moon. So we'll go ahead and click start. And now it's just running away with its captures. And if I wanted to do a full image of the moon, what I would actually have to do is take a series of images where each one is a slightly different view of the moon. And then I would have to basically ensure that there's about a 20 to 30% overlap between the frames. And then I can use a Photoshop stitching algorithm to stitch the images together to get a full image. I've done that before. It takes a long time to do it because it's such a large file, but it's doable. And Zach just asked if I can see Jupiter and Saturn, and I might be able to. I will try and see if I can get it again before it sets. Looks like it's clearing up a little bit in the south, so I'm gonna real quick move the scope so you can see here. I'm just going to and it looks like we're in luck. Ooh. So the answer is yes, we'll be able to see Jupiter and Saturn. I'm just recentering them. need to increase our gain. So there they are. I'm going to move them back into the center. So let's change the zoom here. So now that's Jupiter and Saturn. I'm going to increase the exposure here so you can see it a little bit better, at least the rings of Saturn anyways. There it is. You can see a couple of the moons of Jupiter are being picked up here because of increased exposure time. If I were to lower the exposure, you could see the actual bands in Jupiter and even some bands on Saturn for that matter. But I'm increasing the exposure like this because Saturn is actually a little bit dimmer than Jupiter by quite a bit. You can see it's really overexposed here, where Saturn is only really just now. So actually, I could take an image of this and be able to get a usable image of Saturn. But nonetheless, I think this is a nice view. It's really kind of a joy. Usually, if you're looking at Jupiter or Saturn, you have to move the telescope to very different parts of the sky. But at least now, they're right here to see, from our perspective, hurtling around the sun. We can look back at them and see them in basically the same part of the sky. I just want to stress for anyone that's joined more recently, this is such a wonderful thing because it's been cloudy all day and it literally just cleared up just for this. So anyone who lives in Massachusetts is very, very lucky. So, or rather, really all of New England, even down to New York City, it looks like it's quite clear looking at the radar. So Saturn and Jupiter, we won't see this again for many hundreds of years. An interesting fact, too, is actually this is thought to be maybe one of the astronomical phenomena that might have been the Star of Bethlehem in the sort of Christian Christmas story. And so if it's clear where you are, definitely go outside and take a look in the south to southeast. And you'll see a bright star just above the horizon. If you hold out your arm at sort of arm's length, your fist at arm's length and make a fist, it's maybe 1 to 2 fist lengths above the horizon, at least where I am now in the latitude of Boston. And it's really, it's interesting because it's getting really low. You can really start to see the effect it's having on the quality of the image. So you're starting to see a little bit of a halo around the moon, or rather the planet here. And Kim, it is in the southeast. Oh, sorry, actually southwest. Apologies. Southwest. So because it's getting low and it's through a little bit of clouds, we're starting to get a halo around, and we're starting to see Saturn's a little bit unclear, but you can still pretty much see the rings around it. So when Galileo first turned his newly made telescope onto Saturn, he wasn't quite sure what he saw. And in fact, he drew sort of like almost like 3 circles straight in a line, a large circle in the middle and 2 smaller circles on each side. And when optics improved, that is when you began to have other scientists be able to actually discern the disk of the rings and some of the structure of the rings. And there's actually a very lovely video from the new Cosmos that is hosted by Neil deGrasse Tyson. I think it's like the third to last or second to last episode of this current season. It's on Hulu. It's very, very good. Highly recommended if you want to hear all about the sort of scientific history of observing Saturn and the Cassini mission, which 2 years ago burned up in the atmosphere of Saturn, so it wouldn't contaminate any of the possible biogenic chemistry on Titan or Enceladus. 2 moons of Saturn, which we think might have ecosystems that, or not really ecosystems, but chemical systems which might give rise to life. Titan having a water ice present, as well as lots of organic molecules in the form of liquid methane, ethane. They even have a methane, ethane, basically like a water cycle in a way. They have clouds, they have rain, they have rivers. And then, of course, Enceladus has a liquid ocean. They have salty water jets, actually. And so 2 places where we might be able to find primitive life, or at least the early stages of it. And of course, Jupiter has its own possible moons that could have life. You know, these small little specks here. One of them is Enceladus. Europa, which has most of the, if you look at the sort of data that we have, the appearance of the reddish material on the surface, the gravity, the sort of models that we have of how it could be the way it is now, it basically has to have a subsurface ocean, and it's likely salty, and so a good place to look for life. Saturn's a favorite. I'm sorry that the camera is not color. I'm looking actually with a blue filter on a monochrome camera, and that is because a monochrome camera is much more sensitive for doing deep space astrophotography, which is what I like to do, and so I use different filter sets. I know it looks really grainy now, and so it's really, the reason I got into this sort of hobby is because I had a small telescope, and I was like, gosh, I can see the rings of Saturn. I want to take pictures of it. And it got, it's really hard to do that, actually, with your phone or even with a camera attached to the telescope. And so what you have to do is get something like what I have, where you have a dedicated telescope, you have a special camera, a computer, and so you can track. So you notice that I haven't touched the system at all in the last couple minutes. It's basically locked onto the target and it's tracking, so I can do long exposure photography. And especially with the planets, they actually rotate. So you have to do a video of many thousands of frames, and then you have to actually do something called, to get the most crisp images, derotation, where you actually account for the rotation of the planet in order to get the most detail. And so if I decrease the exposure here a little bit, we might be able to see some bands on Jupiter. You can sort of see that line across the surface. That's actually cloud bands on the surface of Jupiter. Okay, I'm freezing my butt off. I'm gonna go inside and have pizza and a drink. Thank you so much for tuning in. I hope you enjoyed it. Really relish in this. Tonight is the longest night of the year. We will, starting tomorrow in the Northern Hemisphere, every day we will have longer and longer days. So tonight is, relish in this. Think about the year. We can only go forward from here. More and more light each day moving forward. And think about how special it is. This year's been so shitty. And tonight we're gifted with the ability to see two beautiful planets in the same part of the sky forming what looks like a star. And humans won't see it again for hundreds of years. So really, really special.